Hello, IPC people. This is the short video for week 6, lessons 11 through 12 for the week of May 25th through June 1st. Actually, probably May 26th. May 25th is Memorial Day. So this is probably posted on Tuesday, I would guess. Hope you had a good Memorial Day weekend. So let's just talk about some things here. Week 6, so make sure you're using the right slideshow. It looks like this. It covers pages 33 through 34. This is lesson 11. How do we tell if a star is moving toward or away from us? A couple things that we want... couple things just to remember from the last couple weeks. Don't forget, here's our spectrum, and specifically we're talking about the visible spectrum right there, right now, is all we need to worry about. So remember that the red end is the longer wavelength end, and then the blue end is the shorter wavelength end, okay? Also, don't forget about the emission spectra lines. So just to review, remember every single element has an exact spectral fingerprint. So oxygen, for instance, will always look like that. Those lines will always be in those exact places, and we can mark them off. You know, if this was, oh, here we go, 400 to 750 nanometers, and they could be marked off in there, and we could tell exactly where each line is, and it'll always look like that. Okay? Helium will always look like that. They'll be in those exact same places. Nitrogen always looks like that, has all those lines. So the only time they'll look differently is if the source of the light is moving. Okay? Which is what we're talking about today. So, Doppler effect. You've all experienced this before. Here's one. So what happens then as the object is moving towards you, the sound waves of it are squeezed closer together, right? Because it's coming at you, so the waves are squeezed and they become shorter. So they produce a higher frequency pitch. If you remember us playing the guitar in class, we used a short string to make the higher pitch. So the shorter the wavelength, the higher the pitch. And then as the object's moving away from you, if this is you over here on this side now, and the object's moving away from you, those wavelengths are stretched apart, producing a lower frequency sound. Okay, so that's the Doppler effect. So go ahead for more information. There's a video you're going to watch, answer a few questions, and then it's talking about stars. As it turns out, the reason we're talking about this, there's a very similar thing with light. Light will do the exact same thing as it's coming towards you very quickly. If the object is coming towards you, the wavelengths will be squeezed together, and it'll be squeezed towards the shorter blue end. Okay? And if as it's moving away from you, then the wavelengths will get farther apart, just like sound does, and it'll move towards the red end, the longer end of the spectrum. Okay? That's what that is right there. So if the object is coming at you, it'll be blue shifted. If it's moving away from you, it'll be red shifted. And our point here is that nearly every galaxy in the sky is red shifted. So in every direction we look in the universe, all the galaxies outside of our local group of galaxies that are gravitationally bound together, outside of that, everything is red shifted, so we know that everything is moving away in all directions. So that's the basics for lesson 11. And then lesson 12 talks about the Big Bang Theory, so it asks you a few questions about that. It's 35 through 39 in your packet. There's an article to read, so you're looking for evidence of the Big Bang. This we talked about the Doppler effect there. It's really the cosmological redshift. As those photons are traveling through space, they're actually stretched out because space itself is expanding. And so they're shifted towards the red, and that's how we know that the universe is expanding. So that's just one of the pieces of evidence. So you're going to look up a few more. You're going to read about a few more pieces of evidence for the Big Bang Theory. And so briefly wrap this up here. Here's what we know is happening. So the Big Bang, some kind of a Big Bang happened. Who knows what happened before the Big Bang or why it happened or anything like that. All we have is lots of evidence leading back towards some kind of a Big Bang having happened about 13.8 billion years ago. No idea. We may never, ever know what happened before. That's beyond the realm of science because we don't have any evidence for it. All we can talk about is what things that we have evidence for and things that the theory supports. So we got this, the Big Bang, inflation, expansion. Here we are today in an accelerating, expanding universe. And I say it is accelerating because if we look at this graph real fast, this is the end here. The Big Bang happened, then over time, the universe is expanding. What they had expected to happen was that all the mass and gravity of the universe would overwhelm the acceleration and pull everything back together towards something called a big crunch, where the whole universe would collapse back to that singularity it started with. But what's actually happening is it's increasing in acceleration. So imagine you roll a ball across the floor. Eventually, the friction will wear on that and stop it, slow it down, the momentum. So imagine you roll the ball right when you think it's about to stop, it starts rolling faster for some reason. So that's what's happening with the universe. They've been watching it for a long time. So currently, this big crunch thing is not happening. It's actually, not only is it still accelerating, it's accelerating faster and faster. We're never going to notice anything bad happen from it because it's going to be trillions of years before anything like that would happen. But that's the path the universe is on currently. Cool stuff. If we were in class, we would talk a lot more about it, but we're not. So you can read about it and watch those little videos. There's definitely a good YouTube video in there about it. So as always, submit everything to the folders. If you got questions, please send an email. Hope everybody's doing well. I'm impressed again to see everybody, how many people are still submitting things. Just keep on going. Yeah. All right. We'll talk to you soon.